Yes, good afternoon, everyone, and thank you very much for the invitation to be here. I'm going to give a 15-minute presentation on a publisher's perspective on reproducibility and robustness in science, and I think one of the first things you'll see is a lot of common themes coming out across the talks in general in different ways and reflected in different ways. I'm going to say at the outset that I'm not really proposing any answers here, more questions, but I think that's going to lead hopefully to a very active and engaged discussion on really where publishers can pick up the ball on reproducibility and robustness. So this is the overview of what I'm going to talk about, setting the context and defining the scope of the presentation. Go into things that publishers, not just some by Cell Press, but also by other publishers, are currently doing around rigor and data integrity, and then, as I said, looking forward to an active discussion. Is there a crisis in science? Is science in crisis? And you're probably all going to get sick of seeing this Economist front page now. It's the second time up. And there's certainly a lot of discussion of it in the popular press. It's hard to really, for months to go by without some issue around the current state of reproducibility in science coming to the fore. I will say that there is a correlation between funding pressure and the elevation of concern about the reproducibility in science. The last time we really saw a big focus on reproducibility was in the late 80s and early 90s, at least in the US, when the NIH budget was very restrictive. And that's when the NIH developed its Office of Research Integrity, which was the mandate of that era. And there was a lot of focus. All NIH training grants had to introduce training in experimental methods, et cetera, to address what was then the crisis in reproducibility in science. And then when funding became had a little more breathing space, the sort of focus on it went down. And now that we're back in a funding crunch worldwide around research, I think it's coming back to the fore. But it is also being talked about quite a lot within the scientific community. Everybody is talking about it. As you've seen, the NIH is looking to put out mandates related to reproducibility. But what is it that we're really talking about? Because this question of this issue has many heads. It's a bit of a Medusa. So unpacking the issues around what we're really talking about and defining terms. And one thing you're going to see is already there's a slight difference in definitions of how we define terms. So reproducibility, for me, reproducibility refers to other scientists using the same materials and conditions can reproduce the work. So that's a fundamental premise of science, that if I do an experiment and I report everything about how I did it, you can take those methods, you can do the same thing, and you should get the same outcome. Rigor and reliability is a slightly different issue and relates more to the transparency of reporting and how accurately do I report my experimental results and how well do I design my experiments in the first place. You saw an example of experiments that wasn't really well designed, where it essentially went looking for a significant impact of eating chocolate and it managed to find one. But that's rigor and reliability is how the experiments are done, how the analysis is done, and allows the outcomes to hold up in the best cases over time. And then robustness, which is really the holy grail in science, is that the results hold true across a reasonable range of conditions. So it's not just in this mouse strain, in this laboratory, under these conditions. The results may be very reproducible in that context. So there isn't a question with their reproducibility, but they're not robust, because if you use a different mouse strain or you take the mice to a different lab, suddenly you don't see the same results. And so that's considered not a very useful or robust scientific finding. But the holy grail is robustness, where the results hold true across a range of conditions and are reliable and generalizable to other systems. So I just wanted to highlight some things that I don't consider within the range of what we're talking about or focusing on today. Again, important issues in their own right, but not really the same as reproducibility. So one is scientific misconduct, just straight out fraud and fabrication. That's really something that goes beyond the issue of well-done experiments. Are they reported in such a way that they can be reproduced? The evolving nature of science. Science, by its very definition, is set up essentially to be invalidated and to be wrong, and our insights change over time. And that doesn't mean that the originally published findings weren't reproducible or need to be retracted or need to be in some way denigrated, because our understanding has changed over time, and we now see those results in a different light and think of them differently and understand differently what they actually mean. And we're also not talking about a discipline-specific problem. There are many discipline-specific issues within reproducibility, but I think first we need to look at the overall view of reproducibility before we dig into discipline-specific issues. So some contributing factors to the challenges around reproducibility, and this is a long and daunting list, so I just wanted to call out a couple that will stand out as things that where publishers can really engage effectively. So they can engage in, I don't know if this shows up, but reagent validation, access and sharing, data access and sharing. They can in reporting limitations, so space, giving authors space to report what they need to do, being careful about overstatement of claims, et cetera. So those are some of the areas where publishing can really play a role. Other things like incentive structure of science, it's harder to see what we might do in that arena. But so if you're feeling right now like this is all a big tangled mess and how are we going to unpack all of these different contributing factors, you're not alone. I think that's sort of where everybody in the field right now is thinking that there's many competing issues that we need to think about, and how will we get a clear read on what we can do that helps. So things towards a solution. The good news is that the increased attention has a promise of change and a motivation to change. So now that everybody is looking at it, there's likely that we will start to see more and more being done to really think about the issue of reproducibility and how do we move things in a positive direction. You've heard already, again, publications are the output, but it isn't just a publisher's problem. This is a problem that's shared by the entire community. The previous speaker made that point very clearly. It's a problem that we all own, so researchers, authors, reviewers, students, funders, publishers all need to pick up this mantle to really make a difference. So now I'd just like to go through some of the ways in which publishers specifically can and are currently contributing, and where there are areas that we could do more, and all of them involve innovating and evolving our own publishing practices to take some of these issues into account more. So with respect to the reporting and transparency of methods, there's a number of journals looking at revitalizing the methods section and really using it to its full potential to make sure the standard methods section right now is very free form. Authors have very little guidance. They include what they choose to include. Often they just include as done in some previous paper. And at least at Cell Press, one of the things that we're focusing on is really trying to expand and structure our methods section so that it's very easy for the authors to put in all the information that needs to be in there and to know where it goes, and equally that it's very easy for all readers to know exactly what information to expect in the methods section, where it will be, and how they can access it easily. We're also looking at tagging all the information in the methods so that it can be computer searchable in a standardized table of methods where there's just more standardization to the whole process. Obviously, for some approaches and fields, there's agreed upon guidelines for deposit and for data storing. That's not true universally, so we still have to work out how we get uniform guidelines for all fields and data storage options for all fields. And we're seeing the growth in method-specific formats or journals that really allow authors to really drill down into the methods they use and report them separately in a different publication, but in full detail as a protocol or method. Publishers are doing a lot around access to reagents and research materials, policies to make sure that there is access to the materials for published work, and enforcement of that. So Cell Press, for example, requires that all authors publishing in a Cell Press journal make all of their reagents freely available upon request to any non-commercial entity, essentially at free of cost or at minimal cost for handling and processing. And we as journal editors then enforce that requirement. So if someone comes to us saying they tried to get a hold of a reagent and weren't able to, we ensure that they are. And the penalty for not sharing reagents can be a retraction of the paper if you fail to share your reagents with those who ask for them. Reagent deposition into repositories. Jackson Lab is a good example in the biomedical sciences where all the mice strains are stored. There's a initiative to identify reagents like antibodies, et cetera, in papers, so you can be sure from paper to paper with an identifier for that antibody that the papers are using the same antibody, because it can be very confusing and lead to mix-ups in understanding. And similarly for other reagents like in validation and tracking, so you can know exactly what reagent some paper used and make sure that you're actually using the same reagent that they did. And I mentioned already protocols and method repositories, and there are some just examples. It's not meant to be an inclusive list of some of these that are coming up, the Nature Protocols platform, Elsevier's MethodX, et cetera. So, in terms of reporting, we heard already that statistics are a big issue, and that clarity on what the standards for statistical reporting should be aren't out there yet, and there's a lot of confusion in the field about statistics, how you evaluate the use of statistics. Are you using statistical reviewers to assess that? Is that standard practice across all journals? And sort of how do we support the best practices around statistics? Open access to analytical methods, codes, and software. Again, a theme that came up in the last presentation. It's not just the data, but it's all the things that you use to get the data and all the processes used to get the data. And something that's new, and again, this pre-registration of methods and analysis plans. There are some journals now piloting this, where as an author, you put out in advance the question you're going to ask and how you're going to ask it. The journal reviews that and makes a decision about whether or not they will publish the outcome, and because of the interest in the question and the strength of how you're going to approach it. And if they decide yes, then whatever the outcome is, the journal publishes the paper. And that gets around this negative publication bias and also focuses on robustness of the experimental plan, not the outcome. Data sharing, and again, I'm going to go quickly through some of this because we've talked about it already, and I just got the 2-minute sign, and there's one last figure I want to get to, but there's a lot of focus on data sharing policies, how to host data, where can data be hosted. It's a hairball in and of itself because data is huge, it's non-standardized, and it really isn't useful to anyone, the authors or any users, to just stick data up somewhere. You really need a mechanism for people to use it effectively, for people to search for it, for people to combine different data sets because they know what's in them. So that's something I think a number of publishers are really taking on board, how to deal with large data and data sharing. Increased vigilance and screening. So this was pioneered in biological sciences with the Journal of Cell Biology, and Cell Press journals are now screening figures for all accepted papers prior to publication to ensure that the figures are compiled in a ethically and responsible manner, and that they reflect how the original data as it looked. Setting peer review standards and working with reviewers. So again, how did that paper on chocolate ever get reviewed? Who were the reviewers, and who thought it was okay to search for just associations of significance? And there's a number of mechanisms for post-publication corrections and evaluations. So from blog posting and commenting on papers through to corrections and core agenda, matters arising, which are actually papers that challenge an existing published paper, all the way up to and including retractions. Promoting accountability. What are publishers currently doing about promoting accountability? There are new formats and new journals coming out for publishing replication studies. So now where you can just, if you've replicated something, you can publish it as a paper. There are tons of publication options these days. New journals are launching every day. So there really isn't an argument that there's some piece of science that can't be published somewhere. And replication studies can be published and can be found through standard searches. Authorship accountability. How do you ascribe contributorships to each of the authors, what they did, so that they're accountable for their contribution to the paper. And these contributor badges through credit, the credit taxonomy, are growing in popularity. Cell Press now encourages authors to use the credit taxonomy. And then various post-publication formats, I said, for comments, et cetera. Some new reproducibility initiatives that are pretty interesting if you haven't heard about them. The Reproducibility Project in Cancer Biology, which is a collaboration for Center for Open Science, Science Exchange, and eLife, where they've picked 50 highly cited papers in cancer biology and hired out to somebody to replicate all of the work in those papers to determine their reproducibility. Training and education, actually, I'm going to skip over. There are opportunities for publishers to be engaged in training and education of scientists on the topics of reproducibility and robustness. And Cell Press has engaged in a number of these. We've endorsed the NIH principles and guidelines for reporting in preclinical research, and we're very eager to be part of the discussions and the solutions. So here, what I want to close on this last slide, which is really sort of as a sort of thought base for the discussions that are going to come, is sort of how do we think about all of these issues in a framework. And this framework is relatively new. I'm rolling it out here for the first time, so I'm interested to see if it will be helpful to people in thinking about it. But if you think of a typical research enterprise, research project, research finding, or insights, there's sort of a timeline. And again, I drew it as a straight line. It's probably not a straight line, but it generally starts with the amount of supporting evidence to prove that something we know, that some observation is true, is in fact true. And it grows over time from the starting point where you first have an idea, a question, or an opportunity to look at something. At that point, you have no data to support it, but you've got the idea in mind. And over time, you start with a pilot experiment if you're actually engaged in a research project, and you get a little bit of data that tells you yes or no, your idea is going in direction A or B. And as you can see, I've just highlighted some of the key milestones in this building up of evidence. And it continually grows over time. At some point, you can say, okay, where in this process do we know this thing to be true? And in publishing, currently through community standards over history and just from agreement, I've highlighted some of the current milestones that we highlight as being stopping places in what is in fact an ongoing continuum of where we publish. So, for example, after you've had in-lab replication, you're going to likely publish a paper. If another lab replicates the findings in their own lab, they're probably going to publish a paper, probably in a lesser impact journal, but nonetheless they'll publish that as well. These are just sort of representative of where we currently put windows into what is a continuum process. And we can see with some of the new initiatives coming on, I talked about the registry for the data, for the method, the experimental question and the experimental approach. That green box now on the left, there's now a window where you can actually, we call that a sort of milestone definition point. And likewise with preprint servers and the growth of preprint servers, there's now another window sort of earlier before the first publication. And with all we're hearing about reproducibility, there's a pressure to move this current, which I can't really get to show up, the first red box further to the right. So after there's been even more validation, more reproducibility within the lab, more statistical analyses, greater ends, et cetera. But every time you move one of these windows or introduce a new window, there's a whole set of impacts that has on the publishing process, on the funding process. How much data does it take to publish that first red window? What does it take to get to that point? And if we say that has to move further out to the right because we need more confidence in the reproducibility before the first paper gets published, then that slows up science and pushes that out even further. You can say we're going to publish it early and we're going to wait for a later window for it to be defined as reproducible because it's not really clear when that point comes. And over time, one can also take the approach that essentially research is a continuum, and we should have a continuous set of windows that look you could imagine researchers uploading their data every day. What they collected today, they just upload it, and anybody who wants to look at it can look at it. They can see, oh, today was a bad day, the experiments didn't work. The next week it's a good day and 3 experiments in a row worked, but you could get a different view on reproducibility that way. But I think when we talk about policies and what it takes in terms of reproducible research, we have to think of the impact of how we move these windows along this continuum, both for science, for funding, for advancing science, et cetera, for sharing science. So I think with that, I would like to close. Cell Press is very eager to hear from all of you on these issues. We are really looking to make some bold moves in tackling the reproducibility challenge. And so there's my email address if you have feedback after the meeting. So thank you very much.